All right, so video 4. I forgot to finish example 4 here because I forgot to do the domain and range. We talked about what the horizontal asymptote was, but I still got to do the domain and range. So looking at our graph here, we can see that our domain goes to the left and it keeps going to the right. Therefore, it's negative infinity to infinity. Our range, though, does not keep going down. So our range starts at but does not touch that horizontal asymptote at 2, and my graph keeps going up to positive infinity. So there's the domain and the range for this problem. All right, so some definitions here. It says a fee charged for borrowing a lender's money is called interest. Remember, principal is the original or the initial amount of money that's being borrowed. The period of time in which the borrower pays back the principal plus interest is going to be our time, T. And the interest rate is a percent charged for the use of that principal for a given period. Interest rate is R, and you always express it as a decimal. Also, unless it's stated otherwise, the period is assumed to be 1 year. That is, R will be an annual rate. And then the amount of interest computed only on the principal is called simple interest. And so for simple interest, we have this formula here. That's I equals PRT. All right, so for example 5, it says Juanita has deposited $8,000 in a bank for 5 years at a simple interest rate of 6%. We want to know how much interest she will receive and how much money will be in her account at the end of 5 years. All right, so how much money will she receive? Well, first, before I do either one of them, we know that she deposited $8,000. Well, that $8,000 is the beginning amount, so that's the principal. It also says that it's for 5 years, so that would be my time. And time will always be in years, guys. If it's anything other than the years, you need to convert it. And it told us it had an interest rate of 6%. Well, remember, that's going to be our R, but you have to change it to a decimal. So divide it by 100, or move the decimal places 2 places, the decimal place, 2 places to the left. All right, so we're after simple interest, so I equals PRT for A. And so let's plug in what we know. So I equals 8,000 times a 0.06 times 5. And so we calculate that, and we should get $2,400. Now B says how much money will be in our account at the end of the 5 years. Remember the way this formula worked, we just found out how much she's going to get in interest, but she still had that beginning amount. So her ending amount is equal to the beginning amount plus the interest. And so that would be the 8,000 plus the 2,400 that she received. So her ending amount is going to be $10,400. All right, remember, if I'm going too fast, guys, pause the videos so that you can understand it and catch up. All right, then we have compound interest. It's the interest paid on both the principal and the previously earned or accrued interest. Interest that is compounded annually is paid once a year. So they have a formula that's specifically for compounded annually. In a minute, we're going to talk about the next formula, and it can work for annually, it works semi-annually, it works anytime it's compounded as long as it's not compounded continuously. So we could actually use that same formula on this one, but we're going to go ahead and look at this formula here that they gave us. All right, so example 6, it says Juanita deposited $8,000 in a bank at the interest rate of 6% compounded annually for 5 years. A says how much money will she have in her account after 5 years, and B says how much interest will she receive. Well, it's really the same scenario, except now it's being compounded annually. So she's still starting out, I'm going to write it up here this time, save a little room, with $8,000. And let's see, its interest rate is 6%. So change that to a decimal, so 0.06. And it's still in there for 5 years. And it wants to know how much money will she have in her account in 5 years. So the way this formula works, remember the other was I equals. This formula is A equals. So this is our ending amount. And so we're going to use the formula for compounded annually. So A is equal to P times 1 plus R raised to the T. So we're going to plug in what we know. P is 8,000 times 1 plus, our rate is 0.06, raised to the T, which is 5. And so we can just plug that right into our calculators, and it's going to tell us that she's going to have $10,705.80. And then B says, how much interest will she receive? Well, we know the ending amount, and we know the beginning amount, so the interest is the difference between them. So the interest is going to be the ending amount minus the beginning amount. So in this case, we ended with $10,705.80, and we started with the $8,000. So we subtract them, and that'll tell us what her amount in interest is. And it should be $2,705.80. All right, then we have our compound interest formula. It looks a lot like the previous one, except this time it has an N, and that N is going to be the number of times compounded each year. So you'll see like compounded annually, compounded daily, compounded monthly, compounded quarterly, things like that. So N will change based on the number of times it's compounded each year. A is still the ending amount, P is still the beginning amount, R is still the interest rate as a decimal, and T is still the number of years. All right, so we have, if $100 is deposited in a bank that pays 5% annual interest, find the future value A after 1 year if the interest is compounded with annually, semi-annually, quarterly, monthly, and daily. All right, so the difference is our N's going to change. So for annually, sorry about that. I didn't turn my pen on, so it changed slides when I touched it. All right, so for annually, it's once a year, so N is 1. Semi-annually, semi is twice, so twice a year. Quarterly, it's 4 times a year. Monthly is 12. And daily, my N will be 365. So we'll work each of these the same. We're just going to change our N value. Well, we already know, according to this then, that the $100 is our beginning amount. 5% annual interest, so our rate is going to be 0.05. And it says that we're going to find the future value after 1 year. So that means our time is 1. So we can take all of these and plug it in to get our answer. So for annually, we'll have A is equal to P times 1 plus R, which is 0.05, over N, which is 1, raised to the N, which is 1, times T, which is 1. And so when we plug that all in, we should get $105. I'm going to try to change colors here so it's not so much pink all at once here. Maybe it'll be a little easier to see. When N is 2, we're just going to plug it all in. But this time, where it was N, we're going to plug in 2. Put all this in our calculator, and we should get 105.06. Whoops. Notice our numbers aren't drastically changing here. I mean, the more times it is compounded per year, the more money that you will earn or you will pay, whichever way it's going. In this case, it would be the amount you're earning. But it's not a huge difference. So if you end up with one that's like drastic, you better reevaluate it. All right, and then when N is 4, so same formula, same thing, except where N, it will now be 4. And so we plug that in and we get 105.09. N is 12. So I'm going to plug in the 12. I got 105.12. And I can plug in the 365. Of course, and then I got 105.13. Now, when I was talking about you won't see a drastic difference, I mean, they should be around the same amounts, but, you know, of course, the more money that you start with, the more you will earn, so the bigger the change will be, and also depending on the number of years, of course. But you're still not going to end up with like a couple of them being 100 and another one being 500 or 1,000, something like that. Then you need to check it if they're not with all of them within some type of range of numbers. All right, so I know this video is getting a little long, and I'm sorry, but we've got... Well, I'll just put the next one on the next video. So that one can wait a second.